Earlier in the course, we drew the distinction between primitive data types, which include ints and characters and doubles and booleans, and variables of reference types, which contain references or pointers to objects, but of course never the objects themselves. That means it's possible for more than one variable to point to the same object, which is a situation we like to call aliasing. It's not the first time we've heard this word. This happens when you, the programmer, assign one object variable to another. It's also possible, of course, for two object variables to point to different objects of the same type. The possibility of aliasing can lead to some sort of unintended results when you're comparing two object variables to see whether they're equal or not. There's two ways to think about equality and to compare objects for equality. The first is to use the equality operator, this equals equal sign, that we most commonly use with primitive data types. The second is to use the instance method equals. Okay, this method is defined in the object class, and it uses the equals equals operator by default. It's similar to the method toString, which we discussed earlier, and by default returns the name of the object's class for any object that doesn't override it. So if you think, all classes, which are subclasses of object, inherit the method equals, and they use it whenever we don't override it in whatever the receiver object is. So think about this following code chunk. It reads a string from the keyboard, and then it uses both methods, the equals equals operator and the equals method, to compare this string to some other string literal, and then it just outputs the result. This first line is us getting the input. Second line is us checking to see whether that input equals the string Java, and this is always going to display false, because the equals equals tests for object identity. The string Java, the string literal Java, has a different identity than the string str. They're separate objects. This third line with the equals method, this returns true even when the two strings aren't the same objects in memory. It does this if their characters happen to be the same. Now, if at least one pair of the characters doesn't match, this is going to return false, and we've seen this before as well. Now, this can lead to some sort of quirky things. For instance, the not equals operator could return true for two strings, even though the equals method also returns true. Think about that for a second. The not equals operator could return true even when the equals method also returns true. The big takeaway here, which hopefully by now you've understood, is that the equals equals operator tests for object identity, whereas the equals method, which is inherited from the object class and overridden ideally, tests for structural similarity, however we define that as the person writing the class. Now, there are occasions where you will want to actually test for object identity. It happens a lot when you're working with graphics, with graphical interfaces. But for classes like the student class, which we've seen over and over throughout the course, in general, we're probably going to want to use the equals method. So we'll implement that ourselves. We'll consider two students equal if they are identical objects, that's in terms of object identity, or if they are instances of the student class and their names are equal. Those are our two criteria that we, as the developers, have decided upon. As you can see here, this method's going to return Boolean, and it takes as a parameter some object, which we'll call other. Okay. If they have the same identity, this object and the other object that was passed in will return true. Same thing. Fantastic. If other is not a student, we'll return false, because there's no way for a student object to be identical to an object that is not a student. So that makes sense too. But if we've determined that other is in fact a student object and that they're not the same actual object in memory, then what we'll go ahead and do is cast other to a student, point a student variable, which will say s at it, and then we'll return whether or not their names are equal. Key ideas here. We're deciding how we decide whether two objects are identical. We could have said that two students would be the same if both their names and their test scores were the same. That could have been a decision that we could have made, but we chose not to. This depends to a great extent upon our design decisions. Okay, now we'll quickly revisit a problem that we encountered earlier in the course as well, and that is copying objects. Now, we've mentioned in the past that trying to copy an object using a simple assignment statement, the equals operator, not the equals equals, but the single equals operator, that can cause problems. If you take a look at this code segment, This creates two references to a single student object when what we really wanted to do was copy the contents of one student object to another. We have two student variables, S1 and S2. S1 gets a new student object which has the name Mary, and we're just pointing S2 at the same thing. This is aliasing. This is a classic example of aliasing and is likely not intentional. Now, the way we got around this in an earlier unit was we added a constructor that could take another student object and just create a brand new object with all the same instance variable values. This would copy the parameter objects, in this case that means S1, it would copy the parameter object's data into the instance variables of the new student object, which is going to be pointed at by S2. Now we have identical but distinct objects. No aliasing here. And that works fine. But in standard Java, when we might want to copy an object and we're writing a class knowing that that might be something that someone might want to do with it someday, the more standard way of providing a method to do so is implementing the Java interface clonable. This interface lends us the method clone, which is defined for the object class and basically constructs a field by field, variable by variable copy of the object. So now we could rewrite that code so that it creates a copy of a student object. It would look something like this. Student S1, S2, S1 is a new student, S2 equals S1.clone. Now hopefully this looks familiar if you remember the AP image and the pixel objects that we worked with in an earlier problem set were both clonable classes. It's worth noting here that the equals equals operator would return false for S1 and S2, and the equals method would return true for the object and its clone, that is for both S1 and S2. Here's what the code for the student class's clone method looks like. Returns some object, and all we do is we return the newly instantiated student, which will take the name and test scores of this student as parameters. That's it. Now, many of Java's standard classes, like string for instance, they already implement the clonable interface, so they already include a clone method. But when instance variables of some class that we're writing are themselves objects that are clonable, probably a good idea to call their clone methods to get copies of them when we're implementing the clone method of the class that we're writing. We call this deep copying or deep cloning, and it can help save us from a whole bunch of errors. So let's take a look at an example. Suppose we have a class called group project team, and it has as its two instance variables S1 and S2. Well, here's what its clone method might look like. Return a new group project team object, and it takes as parameters S1.clone and S2.clone. We're actually ourselves cloning S1 and S2 for the new object. We're creating new objects, new copies of those two student objects, assuming that there's a group project team constructor that takes two student objects as parameters. We can briefly examine two alternate scenarios for that method. Okay, one is what we just saw with effective deep cloning. We can see we have G1, which was our initial group project team object. And when we make our new object, well, you can see we get our new one right here. And it has as its instance variables S1 and S2's clones here and here, not the original S1 and S2, which exist inside G1 here and here. Now, if we don't clone deeply, we just call the group project team constructor down here with S1 and S2, not the clones of S1 and S2, we end up with two group project team objects, G1 and G2, which both include references to the same student objects here, S1 and S2. That's probably not what we intended, because that means that if we change something in G1, for instance, if we change the name or the test scores of this student, we'll get the same changes reflected through G2. Probably not what you had in mind. Big ideas before you close up shop. You definitely want to know the difference between the equals equals operator and the equals method. Take a look at this segment of code, see if you can predict what the output will be. Think about what happens when an object is assigned to a variable, when we point a variable to an object. How can you get a true copy of a variable, and what is deep cloning? Big ideas for the day. That's it for now.